Good morning to one and all. Hello everyone. Today our topic is clusters of cooperative computers. What is a cluster? Cluster is nothing but to form a group. Cluster is nothing but it is a widely used term meaning independent computers combined into a unified system through software and networking. Here, clusters are typically used for high availability, for greater reliability, or high performance computing to provide greater computational power than a single computer can provide. Here, the clusters are composed of many commodity computers and linked together by a high speed dedicated network. That is nothing but the introduction of cluster. Here, what is a computing cluster? Cluster computing, it is nothing but here the nodes must be homogeneous, that is they should have same type of hardware and operating system. So computers in clusters are dedicated to same work and no other task. Here computers are located close to each other and are connected by high speed LAN bus, local area network bus. Here computers are connected in a centralized network topology. Centralized in the sense in the under a single authority, it controls an organization, one of the organization, it is a physical connection, okay, in network topology, okay. Topology is nothing but it is a structure of a network, okay. The whole system works as a single system. It is nothing but cluster computing. And coming to the concept of computing cluster, here we see computing cluster, what exactly it means. A cluster is a type of parallel or distributed processing system. Here that consists of interconnected stand-alone computers. In the sense, stand-alone computers in like desktop computers or laptop computers which work cooperatively as a single integrated computing resource. Okay, here what is the meaning of the computer cluster? Exactly, that is the definition. Okay, a computer cluster consists of a set of loosely or tightly connected computers that work together in many respects, that they can be viewed as a single system. Here we have seen here, this is the cluster architecture, okay. This is the cluster architecture. The figure explains you that a cluster of servers interconnected by a high bandwidth storage area network or local area network with shared input or output devices and disk arrays. Here the cluster acts as a single computer attached to the internet. This is the cluster architecture. And coming to the above architecture of a typical server cluster, it built around a low latency, in the sense it have less latency and high bandwidth internet connection. Here this network can be as simple as a storage area network, for example myrinet, or a local area network, for example ethernet. Here the cluster, in the diagram, the cluster is connected to the internet via by using a virtual private network gateway. In the sense the gateway IP address, it locates the cluster. And coming to the definition of single system image, what is the meaning of the single system image? The name itself says an ideal cluster. An ideal cluster should merge multiple system images, should merge multiple, merging, it's nothing but link, should merge multiple system images into a single system image. That is nothing but single system image. It is an illusion created by software or hardware that presents a collection of resources as one integrated system and powerful resources. Here, single system image makes the cluster appear like a single mission to the user or customer. Here, a cluster with multiple system images is nothing but a collection of independent computers. What is a collection of independent computers? A cluster with multiple system images is nothing but a collection of independent computers. Here, the table shows here critical cluster design issues and feasible implementations. We have seen in clusters of cooperative computers the cluster, what are the cluster benefits and what are the cluster features, what is the cluster applications, and one more limitations we have seen in a clusters of cooperative computer networks. Here the cluster categorization is we have four clusters categorization. First one is high availability, and second one is load balancing clusters, and third one is high performance computing. It is nothing but high performance computing. It is no longer optimal. It is measured for the system performance. Okay, and coming to the last one, grid cluster. Here we have cluster benefits also. The main benefits of clusters are, first one is availability, and second one is performance, and third one is scalability. We have the cluster applications. What are the cluster applications? Okay, here these benefits, we have the cluster benefits. These benefits map to need of today's enterprise businesses and education and purpose and military purpose and scientific community infrastructures. These are the cluster benefits. Okay, and coming to the cluster application, what are the cluster applications we have seen here? Cluster applications, there are three primary categories of applications that use parallel clusters. First one is compute intensive application. First one is what we have to compute, what we have to manage, what we have to process and communicate information or data. It includes both hardware and software. In intensive application, what is the meaning of what we have to intense here? The data intensive, in the sense what the data intensive computing, it is a class of parallel computing application which uses a data parallel approach. We have to process a large volume of data, typically in terabytes or petabytes in size, and here the data intensive is nothing but it is typically referred to as a big data. Okay, it is one of the application of cluster. And second one is data or input or output intensive application, and third one finally transaction intensive application. We have to transact what the data, it is referred to as typically big data. We have to transact in that operating system. That is the last third application of cluster. We have some important features in cluster computing, that is nothing network technologies and network types, and one more communication protocols, and one of the feature, that is the key feature, or that is nothing but application or operating system, and one more cluster computing feature is single system image, and one more and last finally, that is the feature of cluster computing is quorum. Okay, here in Cluster, we have some limitations are also. The limitation in the sense, typically the latency is very high limitation, and the bandwidth it's relatedly low. We have seen currently there is a very little software support for threading a cluster. It has a single system. Here, the problems exist in the interaction between the mixed application workloads on a single time shared computer. Here, we have the features here. What are the features and functional characterizations and feasible implementations? Here, look at the here of 7 features the in cluster, the critical cluster. First one is availability and support. The functional characterization is hardware and software support for sustained high availability in cluster. And coming to the feasible implementation of the cluster feature is failover, failback and checkpointing, rollback recovery, non-stop operating system, etc. These are the features of a cluster. Second one is hardware fault tolerance. The functional characterization is it is automated failure management to eliminate all single points of failure. And coming to the feature of feasible implementation is nothing but component redundancy and hot swapping, RAID RAID disk arrays, and one more multiple power supplies, etc. These are the features of clusters. And one more single system image. It is achieving at functional level with hardware and software support, middleware or operating system extensions. And coming to the feature of single system image of implementation, feasible implementation is hardware mechanisms or middleware support to achieve DSM at coherent cache level. And one fourth one is efficient communication, in the sense the functional characterization to reduce message passing system. And feasible implementation is fast message processing and it enhanced MPI library, etc. And coming the fifth feature of cluster wide job management. Wide means the very large, we have take the management job by using the functional characterization. It is a global job management system with better scheduling and monitoring. And coming to the feasible implementation of cluster feature, here application of single job management system such as code line, etc. And coming the cluster feature, last but one is sixth one is dynamic load balancing. The balancing the workload of all processing nodes along with failure recovery is the functional characterization. And the feasible implementation here workload monitoring, job replication and gang scheduling, etc. And last one is scalability, process of being scaled, and programmability. We have to do the programs in a computer. We have the functional characterization adding more servers to a cluster. And the last one, the feasible implementation of cluster feature is we have to use of scalable interconnect performance monitoring and a distributed execution environment and the better software tools. These are the critical cluster design issues and feasible implementation of a cluster cooperated computer network. Okay, thank you.